Hey guys, I heard a lot of people say that they had no problem watching the videos last night. I've been tracking the views on YouTube. And it seems to be working out well. This brings us into our second video of the class, which is 1.2 parent functions and piecewise graphs. One of the main skills you'll be learning in this class is being able to picture relationships with variables and being able to graph those variables without using your calculator. Today we're going to be talking about 9 parent functions that are pretty crucial to understanding this class and being able to visualize and see what these actual graphs are. It's an important skill, not just for this class, but if you want to be a mathematician, a scientist, an economist, or anyone that or anything that needs to create mathematical models to solve problems, which is actually used more than what people think. So a thorough understanding of these parent functions is very essential. Okay, if I plot a point on my graph, I'd like for y'all to have it too, because those points are going to help you graph and translate different problems in a few days. So you need to make sure you have those in your notes as well. Okay, so the first one is the easiest one we're going to talk about. It's called the constant function. Okay, basically, like in my graph, I've got it graphed at y equals 4. It's a horizontal line going through y equals 4, as you can see. So all you need to put is f of x. I'm having to write super slow. This is good for you guys, so y'all can write down the graphs as I'm writing f of x. F of x equals 4. I know y'all know this one. You've seen it before in your Algebra 1 class and every other math class, but you still got to have it written down. Okay? So it's a horizontal line, and it could be any number. It could be 5, 2, -5, whatever. Okay? The next one we're going to talk about is the linear function. And I know everyone knows that the linear parent function is f of x equals x. I just have to write really slow in order for this to pick up. So f of x equals x. Oops. That's an x value. Doesn't look like it, but it is. Okay? So basically, f and x, it crosses the origin at 0, 0. So go ahead and mark that 0, 0. And go ahead and mark 1, 1. If I can mark it. There it is. Okay? So go ahead and mark that on your paper as well. That'd be great. Okay? The next graph we are going to talk about, and y'all have seen this before, is the quadratic function. The parent function of the quadratic function is f of x equals x squared. Everyone should know, that the shape the quadratic function makes is a quadratic. And its vertex is at 0, 0. So let's mark 0, 0 as you're graphing. Mark that point. And 1, 1. And 2, 4. So I would label those. It's good to have. I just can't, because it'll take me 5 minutes just to label those. So just make sure you label those 3. Okay? So notice one thing I do want to say about the quadratic. Notice all y values are positive because of negative times a negative is a positive. And it goes through the origin and it makes a parabola. Okay, next, the cubic parent function. We've got, looks kind of like an S, or slight squiggly, not really an S, sideways S maybe. So you got f of x equals x cubed, hence the cubic function. And that's a 3. Okay? Notice this graph only lies in the first and third quadrants because either both coordinates are positive and both are negative. Because an positive times a positive times a positive gives you a positive number, and a negative times a negative times a negative gives you a negative number. So hence they're only in the first and the third quadrant. Again, I want you to do 0, 0, 1, 1, and 2, 8 are your points. Okay? Which brings us into the square root function. If I can click it. There it goes. I think. There it goes. The square root function. Sorry, this graph is a little bit different. I accidentally copied the cubic function twice and left it out, so I had to make my own. The square root function is f of x equals the square root of x. Now, something I also want to point out. When you take a square root of a number, you're ideally supposed to have a positive and a negative. Or not ideally, you do. But the graph only gives you the positive version. Okay? Because if we were to graph the bottom part, it would be a sideways parabola, but it would not be a function. Because there would be 2 x values for every y. I'm sorry, I said that backwards. There would be 2 y values for every x, just like the square root of 4 is positive 2 and negative 2, which is why we only graph the positive values. So the points I want you to put is 0, 0, 1, 1, and 4, 2. Because remember, if you plug it into your calculator, if you do the square root of 4, it only gives you 2. It doesn't give you negative 2 as well. But we all know that it's positive 2 and negative 2. Okay? Which brings us into the cube root function. Cube root function just looks like you took the cube function and turned it on its axis at 0, 0. The function is, and it's actually, you know what? I have it right there. The parent function is right there. Okay? The important values are 0, 0, 1, 1, and we're going to wait. It's going to be off, but it'd be 8, 2. Because if we plugged in the cube root of the cube root of 2, you would get like 1 point, I don't know, 2 something. You'd get a decimal and be nasty. Okay? Just like the cubic function, it'll only be in the first and the third quadrant, because the cube root of a positive number has to be a positive, and the cube root of a negative has to be a negative. Okay, moving on to the absolute value function. There is the equation of the absolute value parent function. Looks like a V. The way I always remember this, V for value, absolute value. Okay. Something cool about the absolute value is if you're looking at the positive x values,